So welcome to this part of the recitation 7, where we are covering an example of LSTM use, basically an example of RNN model. So this notebook first comes from the last semester notebook recitation and is using data and data processing techniques from this tutorial that you have the link here, so you can take time to go through and see all the information that if you need it. As I already said in this recitation, this notebook will help you to implement a recurrent neural network that will perform sentiment analysis. And we'll be using some data set, which is basically a review of different modules accompanied by the sentiment labels that are either positive or negative. And for instance, like what a wonderful plot is going to be a positive sentiment, but I didn't like the main characters, for instance, is going to be a negative one. Here we'll implement an architecture which will have like three different main components. The first part of these elements is going to be the embedding layers, and these embedding layers is going to help us like to produce some words that embedding words that some word that we have. We're going to use it to reduce it to a lower dimensionality because we don't want to use a sequence of word representation like a one-hot encoding, which is not really efficient. And using the embeddings ones actually reduce the dimensionality of what we have into a lower dimensionality that give us a meaningful uh, context for the kind of what we want to do, because it's actually captures the relationship between different words. For instance, like if I take king and queens, this helps us to know like representing these words very close in terms of this and to make sense of the meaning of relationship between these two elements. So after reducing our words vocabulary, our words sequence into low dimensionality here, we'll use it to pass, we'll use it for the LSTM layers because all the input our LSTM layers is going to be now of this dimensionality, and this is what will give us some output after going through the LSTM. And at the very end of uh, the sequence of what that we're given through the LSTM, we get some output that we take through a classic classification layer, which is going to output either 0 or 1 to say that we have a positive review for this movie, or we have a negative review for the movie if the value that we got at the end is 0. So first, for this one, let's try to import some necessary library, which is basically here we need PyTorch, we'll need Torch for the PyTorch module that we'll be using. We're also using Matplotlib, and TQGM Matplotlib will help us to look the distribution of the different reviews that we collected to take some decision of the kind of content we're going to use for this recitation. Apart from that, we'll be apart from that, we first what we need first in this section is to load the dataset that we are using for the work. So the dataset is available here at this link, and we have for each review the labels that accompany these reviews. So after loading the dataset, we try to look at it for some data processing work. So as you can see here, here are the sequence of words in all the reviews that we have, like we put some part, and these are the output tables that we have for that. So for the data processing part, we'll be doing different kind of things. First, we want to remove some non-meaningful characters such as the punctuation, because they are not going to give any additional meaning to the context of the sentiments analysis work that we are doing. So we first need to remove these different punctuation that we have, and then we separate the large string of all the review that we have into different reviews with their labels. And after doing that, we'll replace the word in the review by the index of the vocabulary by first taking all the unique word that we have in the whole data set that we have to make it the vocabulary of the word that we're using. And then we'll also encode we also be encoding the output, which is positive for with value 1 and negative with value 0, we'll be encoding it for our work. Since that most of the work that we're doing here will be with numerical computation, there is no meaningful content we're going to get from these elements. So this is a representation to help our work. And then at the last part, we'll be removing all the reviews that does not have any word inside. Great. So first thing we've done here is just removing the punctuation in this cell. And then the next step, we split all the reviews line by line to get both the labels and the reviews with the labels. And after doing that, we actually try to split them and then get the unique word from it in this step. And as you can see, we have 74,000 unique word in our content, which is, if we're going to use it to do a one-hot encoding for a vector, it's going to be a lot. And we decide then to use the embedding to reduce this one into a lower dimensionality. And in the example of what we've done here, you will see that we use a really small value for this one here. Okay, so after splitting this review, we now pass all the reviews. So we are doing a parsing work, like getting the reviews to a representation using the vocabulary that we have. And so each word will be represented by using the vocabulary index from the set of vocabulary that we have. And then you can see, as we put it here, this is the representation that we got for some of the reviews. Then we also do the encoding here, where we just returning 1 for positive label and 0 for any other output that we have. And then we plot the distribution of our reviews. As you can see here, in this distribution, like they're only the reviews with like at least 200 words, like lesser than 200 words, sorry, looks good, like to help us really predict what is the sentiment that people have on this particular movie. So typically, a movie review will signal like output positive or negative. Just using if we use the first 200 words, we should be able to see whether this review that this person, sorry, is giving is positive or negative one. And then, so looking at that, we now remove all the review that does not have any word inside, and we now truncate all the reviews to 200 words, and that's what we're going to use in our data set for the training and classification work. So here is the session of the data set and data loader. But before going forward, we'll now split the data into different parts. So we have to get the training set, the validation set, and also the test set. So after doing this work here, if we look at the data, we'll see that the data does not have, in terms of sequence for each batch, is not the same thing. But as we are taking for each batch row, we like all the sequence in the batch to be of the same dimension in terms of sequence that we have in for each batch, in terms of sequence that we are passing through. So for that, when you look at the length here, you'll see that all the vector does not have the same shape. So what we're going to do is to pad this sequence for each batch by using the pad sequence function, which is basically going to add some zeros at the end of each sequence to make them the same length for the sequence. So basically, for each batch that we are taking, we are going to have like B, which is the batch size, and T is the sequence of our length. So by doing that way, the maximum value that we have for a sequence here is 200, right? So doing the padding will automatically get all the elements in my batch to be of 200 sequence length. So after doing the representation, we have this output, and now we can create the dataset class. In the dataset class, we have the reviews that we load in, and we have the labels for this one. But one particular thing we are adding in the dataset class here is the collect function, which is going to be helpful for the data loading, and it will operate on each batch of our iteration, because as I already said in the previous work, things that I show you is which is the sequence padding. We are doing this operation on each batch. So the code collect function that we are writing here will be performing this operation automatically for us when we giving it to the data loader, so that for each batch that we are passing through our network, the sequence are automatically padded with regard to the size, to the maximum length of each element, or of all the elements we have in the batch. So we implement this collect function, which is doing the padding, sequence padding operation. And for each data we're loading here, the training data, the validation, the test loader, we are passing to it the collect function for each of the data set class, for each of the data set that we have. So basically, we have the training data, the validation, and the test data. So we're giving them the collect function from each of these object that we've created, and then we load all the data. So the remaining part of the work here is just like taking some samples and look at what is the content what we have inside. Right. So now comes to the part where we are implementing the network architecture of our work. So the network architecture here has the following layers. We have the embedding layers, which is going to convert our word tokens integer that we already created from the unique word that we retrieve from our reviews. We are going now to convert this one using the embeddings layer, which will reduce uh, uh, like this one into lower dimensionality. And this is something that you're going to do in the part 2 of your homework, because you will be converting a lower dimensionality of 37 MFCCs to a higher dimension before putting into your network, your LSTM part, sorry. And then we have the second part of our network, which is the LSTM. And this is defined by its hidden size, the input, the number of LSTM layers that we have, and whether this is bidirectional or not. And after getting the output from the LSTM, we'll be passing it through a fully connected output layer that maps the LSTM output to a desired output size, which is basically the logic that we are getting here in our particular case. So here is the implementation of what we have. Here, we just checking what kind of device we are running our architecture on, our model on, and then here we're using GPU. But let's take a look at the network class that we have here. So our network has the embeddings, which is basically taking the vocabulary size, and the vocabulary size is the size of the number of unique words that we have in the original vocabulary that we have here, which is 74,000, right? And then we have to output some embedding dimension by reducing this vocabulary size to a lower dimensionality, and this is going to be the input to our LSTM network, our LSTM module, sorry. And the LSTM module here requires some hidden dimensionality and the number of elements of LSTM we want to get here automatically. And then we have some dropout probability through all the hidden layers. And we have some other parameters, especially the bidirectional one, which is going to tell our network that we have to output at the end 2 times the hidden dimension, because we specified in here that the LSTM is bidirectional, and if you look at it with regard to what we prof explained in class, this can be bidirectional. So if it is bidirectional, so the hidden element will be, we have one from the left to right, and the other one from the right to the left, which is going to combine 2 different outputs that we have. So we have 2 times the hidden dimension for the output, And this output is going to go through the linear layer to output the sentiment of our reviews. So here, for instance, the output size is going to be 2. So after implementing this one, we just take in each input that we have for the embeddings, then the LSTM, and the output of the LSTM is taken through the fully connected layer to output what is happening at the last timestamp. And as you can see, we are taking -1 here for the output because we are taking inside some element, some input sequence, and then all the input sequence. But what we are really looking at here is what happened at the last timestamp. So the last timestamp is what we represent by -1 here in the sequence of output that we have, which is going to be the sentiment of what people think really about the movie. Great. So here we initialize our network, which is the regular thing that we do. The vocabulary size is the length of our vocabulary +1, because remember that for the padding operation that we are doing, we are actually appending some zeros in our word, which was not there before, right? So this is going to give one additional token. That's why the length of our vocabulary size is the length of the vocabulary size is the length of our vocabulary +1. So now the output size is 2 because we have two different states, either positive or false, positive or negative. And then the embedding dimension is 64, the hidden dimension 256. So the output of this one from the LSM layers will give us 256 times 2, which is going to be the input for the linear layer. That's what you have here. And after creating this network, we set up the loss function using the cross entropy loss, the optimizer, the scheduler, and everything as usual. And we create the training loop, which is the usual one that you have, the training function, which is the usual that you have, the validation, and now we create the training loop where we are running for a number of iteration here. We just run it for 20 epochs. And as you can see, at the end of training, we're getting some nice accuracy. After training our networks, we perform the test with the validation data set. As you can see, the validation accuracy was 76, but for the training, we get something like 75, which is really, really close and nice accuracy, right? And using these models that we've trained, we try to predict what is the type of sentiment that people get by using some example. As you can see, someone say, the worst movie I've seen, acting was terrible and I want my money back. Just with these few words, you can realize that this is a negative sentiment that someone has about the movie they watched. So when you perform the prediction, the class output that we have is negative, as the original one. And we also did it with another example. For another review, they say this movie had the best acting and the dialogue was, and it was so good. I love it. And when you predict, you see that the output is positive. So as I was explaining so far, this is just an example of taking through the network a sequence of words. And at the end, when we look at all this sequence, we are actually predicting whether what people think is a positive or a negative sentiment about the movies that they watch. So thank you for going through the notebook. You can take time going step by step through all the cells and try to understand. And if you have any other question, just post it on Piazza and we'll discuss. Thank you.